Okay, we'll look at another example with definite integrals. Total population in a ring around the city center. In most cases, that's what we're doing is population, but in all reality, any function that you have a density, okay, d of t here is a density function, we can calculate the accumulation. For instance, the second example, you see lava deposits, right? So it's not a population of a rock, but how much? What is the quantity? And in this case, it's tons. So we're asking how many tons of lava was deposited. Okay, so looking back at the formula, we have 2 pi t d of t. T is our variable of integration, so therefore that will remain a variable. We don't substitute a value in there. D of t, like I said, is population density function. And then this 2 pi, that's part of the formula. It is constant, right? Pi is not a variable. It is constant. And we won't look at exactly where this formula comes from, but the 2 pi, usually pi comes in when circles are involved, right? So we're looking at population density from a city center. So if here's our center, within a certain distance would be a circle. So like within 2 miles, or for this example, 2 between 1 and 10. So we would have a ring here. In the first example, we say within 5. So, it'd just be talking about within 5 here. But between 1 and 10, we'd get this ring here. So this volcano erupts and it shoots off lava. We're calculating the approximate amount of tonnage of lava deposits within that ring, 1 to 10. Okay, let's jump into some examples then. So in 2012, the population density of a city t miles from the city center was 120 e to the negative 0.65 t thousand people. Okay, be careful of the units per square mile. That last thing about this formula is over here I said per square distance because it could be miles, kilometers, feet. I mean, whatever unit they give you. Okay. So this is d of t. That's our population density. And then within 5 miles means from 0 to 5. Right? So our population, we're going from 0 to 5, 2 pi t, it's just part of the formula, multiplied by the population density, 120 e to the negative 0.65 t dt. And then remember, whatever result we get, it is in thousands of people. Okay. So 2 pi is constant. We could just factor that out. Now when we integrate the rest, we have this t, and then we have this. So, well, actually, one more thing. This is all multiply, right? So let's pull out the 120 as well. Might as well. Okay. So now we only have that e function and the t. We can't use u substitution because eu du, right? The derivative of that is negative 0.65. I don't have that. So we have to do it by parts. By parts, remember the rule is that let u be typically the easy part. We'll just let u be t. Then du is just 1, right? 1 dt. And dv is that e to the negative 0.065 t dt. And when we integrate that, we get the same thing, negative 0.065 t divided by negative 0.065. Okay? So, out front, we have this 240 pi. I'm going to do brackets here. uv minus v du, right? uv minus v du. So we have t times e to the negative 0.065 t over negative 0.065. We range that from 0 to 5. minus v du. So I'm going to go ahead and factor out that negative 0.065. So let's make this a positive 0.65, 0 to 5, e to the negative 0.065 t dt. Oh, I'm sorry, I'm getting ugly here. That's scratch work to do or by parts. The rest is the actual problem. Okay, so first let's take care of this here. Substitute 5 and 0. So when I plug in 5, so we still have this 240 pi up front. Plug in 5 with 5, e to the negative 0.065 times 5. And I'm copying, I just noticed copying that wrong. Negative 0.065. Negative 0.65, right? So easy fix, that decimal is just off in a couple places. I had it right at the beginning, I don't know, sort of reading it wrong. I think it's because usually I don't write the 0, I just go negative 0.65. So anyway, minus 0, right? Because if I plug in 0 for t, 0 times all of that is just 0. So that's good there. And now we have plus 1 over 0.65 e to the negative 0.65. That decimal again is wrong. Over negative 0.65 from 0 to 5. Now, no matter how you look at this thing, it's ugly, right? We're going to need a calculator. The last step I'll kind of just clean up before I use the calculator, though, is 5e negative 0.65 over negative 0.65 is this here, plus we have a negative times a positive. It's a negative 1 over 0.65 squared. And then plug in 5e to the negative 0.65 times 5 minus plug in 0, so e to the 0 is 1. And now I'd use a calculator, and we get about 1490.4928. And remember, this is thousands of people. So better yet, right, I mean, we could get that exact 1490493 if we round. So 1,490,493 people, or 1.5 million, depending on where we want to round it. Alrighty, that was a tough one. This next one shouldn't be that bad at all. Okay. So we have this density function. Remember, the formula says between 1 and 10, right? So we're going to get how much lava from 1 to 10, 2 pi t, and then the density function is 11 t squared plus 10 to the negative 2 dt. And like I said, it shouldn't be as bad. I think it just looks ugly. Okay. So now let's take out all these constants. 2 pi and 11, we can take that out. Actually, before we even take the 2, I notice here, right, I do have this t, but we always want to try u substitution first. If I let u be that ugly stuff, t squared plus 10, then du is 2t dt. Okay. Well, in that case, I have 2 and t and dt. So there's my du. And then all of this here is just u to the negative 2. So u negative 2 dt. So what did we not use is the 11 and the pi, right? So let's just pull 11 pi out. Now, also, I like to change the bounds. You don't have to, but we have t ranging from 1 to 10, right? So if t is 1, then I'd have 1 squared is 1 plus 10, so 11. So therefore that 1 changes to 11, and then u is 11. If t is 10, I'd have 10 squared plus 10, 110, then u is 110. All right, now I don't need to go back to the t's at all, right? And I just noticed I wrote dt here. It's now du. 2t. All sorts of mistakes. Oh, du, yeah, that's right, I'm sorry. 2t dt is du. I just didn't copy it correctly from there to there. Okay. Moving forward, now this integral is nice and easy. U to the negative 2 just becomes u to the negative 1 over negative 1. Range it from 11 to 110. And multiply that by 11 pi. Okay, so u to the negative 1 means 1 over u. And I'm going to go to factor that negative 1 out. So we get negative 11 pi times 1 over 110 minus 1 over 11. And, you know, getting a calculator, it would make more sense. But we could go a bit further, right? Multiply by 10 over 10 here. Then I'd have negative 9, negative 11 pi times negative 9 over 110, because 1 minus 10 is negative 9. And 11 and 110 can cancel to 10, and then negative times a negative, 9 tenths, and we have a pi. Okay, and it's in thousands tons of lava between that 1 and 10 kilometer mark, but you know, that would be weird to answer something like that. So plugging in the calculator comes out to 2,827,000 tons, or 2,827,000 tons.